Hi, I'm Casey.
I'm Brian.
And I'm John.
Today we're going to be talking about our project to represent a data structure in an aesthetically pleasing way. We call our project Library Hash. In it, we relate the concept of a hash map to a library and make it interactive for our audience by touching on a wide variety of mediums to make an effective result. But to better understand Library Hash, you need to see how we got here.
Over the next few minutes, we are going to give you a brief tour of our project, how it works, and why we choose to represent it in this way.
To start things off, let's talk about the idea.
When thinking of the data structure that we were going to represent, we decided that hash maps were a great choice. Hash maps are generally not taught thoroughly enough, and hash maps from a programmer's perspective can be kind of confusing. In actuality, hash maps are rather simple and intuitive to relate to in real life. Now, our original idea was to relate a hash map to a vending machine and the coin mechanism inside of it. We soon realized the flaws of this design as well as some of the potentials. When we then pondered the potential of using the keypad on the vending machine as a way to relate to hash maps, we thought it'd be a good concept, but we realized that what would better fit the concept of a hash map and also make it far more clear would be using something like a library where the Dewey Decimal System is present so that each object could be related in that sense. So let's look at the bookcases that we have in this Maya scene. In Maya, we've created 3 bookshelves with a variety of books of different colors and shapes and sizes, all aligned on multiple shelves and multiple rows. What this allows us to do is represent each one of these objects, or books in this case, as a different value to be stored in a hash map, or in this case our library. As we move through the different books, we see that because a lot of them are the same and they don't appear to be organized in any certain way, it becomes very difficult to navigate the scene to find a specific book. So what we plan to do with our scene was to show that different elements of a hash map make finding books easy once you have a key. Furthermore, we wanted to show how different areas of the hash map could benefit by deletion, insertion, and also through the organizations of collisions and how those are handled in a hash map. So when we find a particular book, for in this example we have the Steve Jobs biography, it becomes much easier to find when it stands out from the crowd, just as it is here. But who is this for? Brian, maybe you can answer that question.
Our audience consists of middle school, high school, and other students who are beginning to be exposed to computer science and data structures. One of the challenges that came about was how to take the ideas we wanted to represent and animate them in a fun and engaging way. Our goal was to help the user better understand how these methods work by relating it to a system that most people know or at least have heard about. For this reason, our scenes we compose in Maya have objects that shift, disappear, and bounce to help engage our listeners, as can be seen in the timeline we keyframed below. The biggest reason why hash maps are used is because of its fast lookup times. We wanted to convey this fast lookup time with something that is actually used in real life. Thus, we came up with the relation to the library system and having a book be the value stored and its corresponding Dewey Decimal number as the key. By animating a small library in Maya, we were aiming to convey in 3 videos that hash maps and a library system can be an effective metaphor. Within these scenes, we discuss some of the benefits and pitfalls of the structure as narrated by us. But how do we make videos interactive? John, maybe you can enlighten us on how we can accomplish this?
Well, we used a variety of technologies in this project, but the 2 main technologies that were used for most of the project were Autodesk Maya 2011 and HTML5. But they were not the only technologies used. We also used iMovie, QuickTime, Tumult Hype, and YouTube to wrap in one great package for our audience. We used Maya to create and texture objects, animate them with keyframes, and render clips. Before this project, I personally had very little experience with Maya. Learning how to do all those processes in Maya was both an interesting and challenging experience. We used both iMovie and QuickTime as post-processing techniques to polish, narrate, and add audio to the clips that we made in Maya. And Hype was used to create and animate the HTML5 website, which is what makes our project interactive. Through the website, the user can decide what he or she wishes to learn about hash maps first. Allow me to show you what I mean. When the user first opens the page, they are presented with an animated menu to enter the site and begins the process of engaging with our project. By making an HTML5 site, we are able to connect with our users on a variety of platforms, all of which are independent of operating systems. We are looking at the website through Safari currently, but someone from our target audience who uses Internet Explorer could obtain the same experience. By clicking on a corresponding book that may appeal to them, they are able to see what topics will be covered in the video. And the YouTube video below needs only to be clicked to watch the scenes we discussed earlier.
We hope you enjoyed learning about Library Hash, our data structure representation for Project 2. Thanks again.